Alright, hey everyone, welcome. Today we're doing FRQ number 3. First part asks for a free body diagram on the block. So start off with just drawing M. So basically it's a force F pointing diagonally downwards. FK, which is just should not be that long because it doesn't act as much on it compared to F because it's moving to the right. There's an F of G and F of N that's much bigger than F of G since there's two forces pointing down, so F of N must be bigger. Okay, now for part B, it asks what you to draw a graph that represents with the slope representing A. So for the I would first set up delta x equals VIT plus 1/2 AT squared. However, the object is at rest, so this cancels out. So I'll just get 2 delta x and I multiply 1/2 over. I divide by t squared, and this is equal to A. So rise over run. So rise, so my vertical, I would graph as 2 delta x, and then my horizontal, I would graph as t squared. And so now just asked to fill in the table that was provided. So I have it here. So now the data would be 2 delta x, and this one would be t squared. Units for this is seconds squared, and while the units for this is just meters. And so now I just plug in what I got from before. So for the first data, 0.036 times 2 is 0.072. 0.234 times 2 is 0.468. 0.493 times 2 is 0.986. 0.729 times 2 is 1.458. And then 1.521 times 2 is 3.042. So now I'll just take the times squared. 0.2 squared is 0.04. 0.51 squared is 0.2601. 0.74 squared is 0.5476. 0.9 squared is 0.81. And then 1.3 squared is 1.69. And that's it for part B. Alright, going on to part C now. Asked us to graph data given in part B. So let me there you go, put that there. So I'm gonna set up my axis now. So the x-axis or horizontal axis, I would say would be t squared, and this is just in seconds squared. And then I would say the vertical axis is just 2 delta x, and this is in meters. My scale starts at 0. I'm gonna increase on the horizontal by 0.4 each time. And then on the vertical, I would increase by 0.75 each time. Okay, so the first point, t, is 0.04, y is 0.072, so that's about like right there. Next point is 0.2601, and then the y for that, or the vertical is 0.468, so 0.2 is about halfway between the first box, and then about halfway up, so I'll say like right here. And then next point is 0.54, and then it's about 0.986, so I would say it's about like right here. Next point is 1 or 0.81, and the vertical is like 1.4, so I would say next point is about like right there. And then the final point is 1.69, and then the vertical is 3.042, so I say the point is like about right there, I say. So drawing a line through this, I'll try to get line of best fit, so that looks like about there. So yeah, that's part C. Alright, moving on to part D. So that's to find the acceleration using the line. So I can just do rise over run. So I can just do 2 delta x over t squared equals a. So I'm just gonna do the last point. It's probably easiest. So I'm gonna say 3.042 divided by 1.69, which gives me A is 1.8 meters per second squared. And then it's positive because acceleration is a vector. So as a direction, so I have to plus. Alright, moving on to part E now, asking us to derive an expression from UK. So I'll set up the net force in the x direction, which is f of x minus f of k equals m a x. F of x is just f cosine theta, while f of k is f n mu k. M a x. I can expand, or I'm going to subtract f cosine theta over, so get negative f n mu k is equal to m a x minus f cosine theta. F of n is equal to mg plus f sine theta mu k. Since I'm trying to isolate from UK, I'll divide the negative over, and then after that, I'll divide mg f sine. So I'll just be left with mu k is equal to f cosine theta minus max over mg plus f sine of theta. Alright, so now going to part F. And part F, part F is just asking to find the frictional force. So I'll just set up f of x minus f of k equals ma. So I can rewrite this, just say f of x minus ma equals f of k. So f of x is just f cosine of 60, and then f of ma is just 2 times 1.8 equals f of k. F is 12 as given by the question. Cosine of 60 is equal to 1/2 minus 2 times 1.8 equals fk. Putting this in your calculator, you get that f of k is equal to negative 2.4 newtons. It's positive 2.4, but it's negative because fk acts against it, so negative. Moving on to part G. Part G, let's do down here, more room. Part G just asks to find the coefficient for kinetic friction. So using the equation derived in part E, because it's like the same physics basically, you get that uk is equal to f cosine of 60 minus m is 2, a of x is 1.8 over m of g, 2 times 9.8 plus 12 sine of 60. Let me just replace this f right here too with 12. So when you do this, you get 2.4 over 30, which is 0.08. So you get mu k is equal to 0.08. That's it for these two parts. Asked to find what happens to A if the theta is decreased. So first off, I would want to set up the net force in the x direction again. So it's just f of x minus f of k equals max. So this is just f cosine of theta minus f n mu k. So this is f cosine of theta minus mg plus f sine of theta mu k equals max. So if the theta were to decrease, then cosine of a smaller angle gives you a bigger number, so this whole amount there increases, and then sine of a smaller angle decreases, so this decreases. So since you're adding by a smaller number, fk becomes smaller, and so you're subtracting by a smaller number. So if this increases, or if f of x increases, f of k decreases, then the net force gets bigger, and so acceleration also increases. Alright, now for part I, just ask to draw what the graph for the acceleration is time. Sketch the shape. So let me plug this in real quick. So I'm gonna label this graph as t in seconds, and this is a in meters per second squared. And so the graph is a constant horizontal line because the acceleration never really changes. Now for part J, paste this in again. As for the velocity versus time graph, so this is time down here in seconds, and this is v, meters per second. And so since the acceleration was a linear horizontal line, that means that the velocity graph is a linear increasing line like that. And then finally for part K, it just asked for a position versus time graph. So this axis down here is just in seconds, and this axis right here is x, units is in m. And so since this the velocity graph was a linear straight line, this is a quadratic increasing line that looks about something like this. And that's all for this FAQ. Thank you for watching, and we're ready for the next FAQ.